Appreciate being here. I have plenty of material for you and encourage questions, maybe bunched up toward the end, but because I want to give Rochelle her 45 minutes as well. I'm Rob Peglar from Symbolic IO. Alan is here with me from Intel, and Tom Talpe is virtually here. He's on the phone in the back, and Tom is with Microsoft. But as Stephen said, I'm here representing the SNIA. I serve as a member of the board of directors on the group, and we have lots to cover, so let's dive into it. These are the three people I talked about. There you go. Now, it's the Alan, Rob, and Tom show. This is what we do. So if you're not familiar with the SNIA, I'll give you a little background. We have 400 some odd member companies, individuals, organizations, and whatnot, but one in particular that's very germane is the Solid State Storage Initiative, or the SSSI, if you like. And they have a mission of education, of developing and promoting models and architectures. Again, not products. We are vendor neutral. We don't advocate one product over another. And then collaborating with other industry alliances as well. And we have a lot of that activity going on, especially in the SSSI. So that is a very active part of the SNIA. Now, in terms of media and resources and papers and whatnot, I encourage you, if you look at the bottom bullet, the SNIA.org/PM, uppercase PM for persistent memory. That is the classic go-to place if you want to look at these resources, and there's all sorts of videos and white papers and resource sheets and lots of stuff, summits and webcasts. We do on demand. We record a lot of our webcasts, a lot of our summits, and that's where you can find it. So SNIA.org/uppercase PM. That's the place to go. All right, let's talk about PM, persistent memory. It's a really fun thing, trust me. Right? So we know as an industry that memory and storage are converging. In fact, they're already there in lots of different ways. But this slide, a little depiction on how you see today folding in memory as opposed to or combined with storage, and some of what we think at the SNIA are the implementations. So you see a growing use of persistent memory, and then different forms of DRAM, dynamic RAM, which by definition is not persistent. It's volatile memory. But there's lots of different packaging and methods and integrations that are happening in the DRAM space as well, on package and off package too. And I won't, again, this is not a lecture on all the different types of them, but the point is there's lots of forms of memory, and there are more that are growing over time, especially in persistent memory. Right? So you're going to see this hierarchy change over time and become increasingly useful, if you like, in the memory portion of that, and in particular the persistent memory portion of that. So here's the vision, right? If you had to think about persistent memory, 25 words or less, right? So we bring storage, we the persistent memory folks in the industry, we bring it to a memory slot. So think of it, one way to think of it is storage in a memory slot. Right? So think fast like memory, persistent like storage. Right? Strong like ox, right? So fast like memory, persistent like storage. But storage in a memory slot, and quite literally that is a good way to think about it, at least at this point in time. And there's all sorts of use cases, as you can well imagine, you know, having a persistent media in the DDR4 today. There are obviously memory channels yet to come, but having persistent memory in that speed of channel is a very, very interesting thing for lots of different use cases. So now there is a taxonomy, a hierarchy of memory now, just as there is, and we storage geeks know this, a hierarchy of storage, if you like, and we tend to think of it that way, but non-volatile memory, persistent memory, is a subset of that. So there's really two basic buckets, if you like, of non-volatile memory. There is disk-like, I have to say that carefully, disk-like non-volatile memory, right? Accessed like a disk. It is a block storage semantic, right? And it appears as a disk drive, if you like, to an application. So you see a disk drive, a LUN, call it what you want, right? There's a block range that you can access, and you do the normal block storage type activity. on that. So that's disk-like NVM. Right now, memory-like NVM, which is persistent memory, right, is a very different thing, right, because it appears as memory to applications, not as a block storage device. So it's not a LUN, it's not a volume, it's not a disk, it's memory. It has a virtual address range. It does not have LBAs and links. It has a virtual address range. The CPU accesses it directly, just like it does what we think of as memory, which turns out in most cases to be dynamic RAM. Right, so you load store from a CPU into this address space, and now you are persisting your data by definition. Yes.
Is that a use case for in-memory applications such as databases and all the way kind of to backup, making sure that the data is persistent in case of a crash or something?
Exactly, and we'll talk about that. We'll talk about fun things like atomicity and persistence, right? Okay. But you're exactly right. So again, by definition, if the CPU stores into said virtual memory address range, that data is now persistent.
The disk-like non-volatile memory, memory is accessible as an address, byte, byte or word and stuff like that.
Byte addressable, correct.
So how does this disk-like non-volatile memory actually work?
So the disk-like NVM, think of it like a persistent RAM disk, if you like. The semantics are different. I address it by LBA and length. I don't address it by a virtual address.
I would qualify
the
the Diablo as
CPU
that.
is doing I/O. It is issuing I/O to the kernel as normal, and this works in all sorts of different environments. So, and we'll get to some of the differences. So instead, Ray, instead of doing read-write, you do read-write to a disk. You do load store into memory.
I understand this logic.
So a persistent RAM disk or disk-like non-volatile memory appears as a drive to an application. It does not appear as a virtual.
Why wouldn't you just call it disk?
What's that?
Why wouldn't you just call it disk?
It is a disk, but it's in the memory channel. It's not a disk on a storage-like channel.
That doesn't sell things.
Right? Oh, thanks, Dave.
So here are the characteristics, again, of persistent memory. Byte addressable from a programming point of view. So if you're an OS designer, an app designer, you are using it as a byte addressable medium. Right? Load store, memory-like performance, supports DMA. Again, it's just another form of memory. It happens to be persistent. So I can do DMA or RDMA against this address range. And the latency curves are much more predictable than a peripheral. And remember that word from your von Neumann study, right? There are CPUs and peripherals. I just love that word. So you can think, if you like, think power-protected RAM. But that's persistent memory.